And we finished the class definition, aggregate function for objects, and we talk about this information hiding, right, and separate compilation, right. This time class, we actually do not look into that, but actually we jump to look at the rectangle class, right? So this one right here, I will actually spend some time to look at this, okay? Because today we are going to study more class. So here we actually, it's a .h file. So as I told you, the basic definition will be put into .h. So in C++, the .h file actually sometimes heavier than the implementation file. So you have this string definition. That's a different namespace, but you actually don't need a namespace. You can put in a normal namespace. That's fine. And then after that, you have time. You put in the hour, minutes, second. You have increment, set, get hour, get time, get minute, get second, and compare to other time. That's length, convert to toString. Okay, and then there's a equal sign overriding for the equal signs. Okay, I think these are okay. These are some functions, and then private data fields. These are some typical class definition right here. So this double equal sign actually is override the equal signs, and so basically the toString and equal sign in the Java class, as I mentioned, there are two important inherited functions from objects. One is equals, one is toString. So right here, you override toString and equal by doing this instead of using the Java type of function there. But that's fine. We keep the two underline string for data type, and then we keep the two capital string for the aggregate function for a class. Okay, so basically each module you would need to put a .h file that has a data field, function prototype, user-defined data type, inline function, struct union, and some overriding function, or sometimes the template into that function file. And we see this overriding right here, and template is like put a string or something in here, so you can use that in the same domain you have. So that implementation file is right here, okay? So that part I don't spend time on it. And then we can also override the different redirection functions as well. And then for a member, you have a dot for the data field selection, and for a pointer, you have this. So remember this, actually the fundamental difference is like, I have class similar to structure, okay? Class similar to structure. And then if you actually, you have an alias or variable A, you directly access some field. This one is A.x. And this one is A.y. Okay, and if you indirectly access it, you would need to do P pointing to X, P pointing to Y, okay, using the arrow. Okay, that's it. And then header file, you have IO string, F file string, something like that, okay. And C and CL are two objects. So C and CL have some function like get, ignore. Get, ignore is like, this one is ignore 100 line. So it will actually skip 100 line. If you put one, it will just consume the new line mark. Okay, that is actually more commonly used. To declare a file string, you actually use the if string, my in file, and then open the file. Okay, and remember that my in file itself, if you do indirection using something like if you use this different file file input or output, if you do this, something like this, you can actually check by doing while and then put this whole statement in there, or just my file in separate command to check if the file is already meeting the end of the file or not. But usually if I try many times with this myfile.eof function, it doesn't work for me. So I actually prefer this one, okay? Is that okay, Eric?
Yeah.
that EOF file actually doesn't work for me. Okay, but one thing to explain is like one thing to explain is like what? One thing to explain is like if we have C in, okay. I'm sorry to this, okay. And this whole thing after the operation still be C in. So when you do C in, actually, is combine the function that before getting A and then after getting A, you will actually check the status after getting A. So that actually already consume certain symbol, and then you will check whether that one you really get the data or not. Okay. The next one is each class has its own file, and you can have separate compilation. And that H file sometimes, if we just define some structure or something, it doesn't need to have the implementation file. You can use that and include to different program for them to use. Okay, and then you can also have that and put into a set and also include it in one module, say same time.cpp and time.h. So sometimes the time.h got included by the .cpp and also by the main program. Okay, and eventually this one you need to link together. So what the difference is like, if I don't have the .cpp file, if we don't have this, then when we compile, it will be G double plus, okay, and then client.cpp, and in client it actually has a main function, okay, and then -o something, okay, and this in time.h actually just need to be included into that CPP file, okay. But if you also have the time file, implementation file, then what you need to do is like G double plus client.cpp and also time.cpp -o and then say client or something, some program. You will generate a client.exe, okay? So you need to put two implementation file over here, but that actually still don't need to be put there when you do outside compilation, outside of dev C double plus. Is that okay, Eric? Hello?
Yeah.
And we use the time header to avoid the duplication. Constructor, we talked about this already. So constructor, actually, we have different format. We have the example. So here, this part, we just omit it, okay? And then right here, instead of using the use of the constructor have many different format, okay? Number one, if you do my class A, this one actually you will call the default no argument constructor, okay? Second one, if you do my class A with some parameter, or A this in C double plus 11, that actually will call the constructor with parameter, okay, these two. And then the next one, if my class A equals B, it will use the copy constructor. Or you use my class A parenthesis B, B is another my class object. It will also, these two are the same. It will call the copy constructor.
So which one should I usually use? Because
all of them are fine. All of them are fine.
I feel like they do really similar tasks. So.
They do the same thing. Everyone.
So is it better to put it in the heap or the stack, or does it not matter?
Put in the heap usually is when you need a use pointer. That's number one. If you need
why do you want to put it into the heap? Like
that actually is like tree or linked list. Sometimes you delete and then you free it.
Oh, okay.
You know what I'm saying?
So if you don't need to free it or anything.
Say I do everything is like array. It's actually fixed size. You don't often do that, right? If you have fixed size, you actually don't often do that. your array or something like just a structure that don't actually grow or shrink, right? So usually when we do that is because of a link structure. Because the link structure, you want to do the pointer more. Because link structure itself is a dynamic memory allocation and deallocation, right? So this part actually usually is for something more like if my class only has some array in there and something like that, or I'm not putting it into a linked list. So this will be used, okay? And then actually here, actually, we have that, this one actually create a pointer as assigned into it, okay? So let's continue. I'll go to some link structure today, okay? So the header file, we usually put the class declaration, function prototype, enumeration stuff in there. We know this already. So this one called detect regions. So detect region, we have the constructor detect region, and then file name, and set file name, save region, something like that. So we have the vector plate, okay? So this one actually should be some sort of, I think it's related to license plate or something, okay? And here, what should be put into the implementation file? In implementation file, we usually put the function body, internal variables, okay? So that's put in there. So what to make things clear is like that edge usually put something that you want to share with other people, and then implementation file you actually put something you in detail and larger implementation like functions. Okay, so how to determine where should I put the code? The simple question is like, if I change this, where I have to change code in other file to make things compile again? If yes, you put into the header, you know. So that's actually those data are shared. So if the question is, if I change this, if a variable I change it, do I need to change the other file and compile it again? If yes, say my client that h need to that CPP need to be changed. If my time.h change, in that case, okay, I would rather put into the time.h, not time.cpp. So those things that actually put time.cpp is actually hide from the other people who want to use it. So actually it's something like that CCP file is like in here, that H file is an interface. Okay, so for other class, you want to use it, you just need to know about that H file. You don't actually need to know what's inside of the CPP is the implementation. Okay, is that okay, Eric?
Read this real quick.
What?
Let me read this.
Yeah. Is that okay?
Yeah.
So basically, that H file is like interface. And then the CPP is implementation. So implementation, you hide it from other people. You don't want to let people see it. So whoever want to use my, say I have a node, right? So my node.h actually is outside, it's the H file. But my node.cpp is inside. So I can change my code by myself, but the interface won't be changed. So whoever use my file, my module, they don't need to know about my CPP. It's just like if somebody changed version for the std lib.h, right? And the CPP file actually got changed, but my std lib.h never changed. So people just included the .h file. They thought that it's always the same, but it is not. Every version of the new installation will be different, okay? Will be different for CPP part. So header file, you can also put inline code, template, and constant. And actually, in fact, the templates can only be put into the .h file. Okay, whatever template T or something, okay, or class T or type name T, okay, and then you follow by something something like class definition. This one, if you have this one, the whole class, this thing must be put into .h. Okay, never put that into your .cpp file. So sometimes the .h file actually got bigger and bigger now. Because of the .h file, why they need a .h file with the template? That's because when they compile, they generate new class. And the template is the template for class. It's not template for object. So they need to create class to inform other people to use it. Then it means that it could be sourced in header file. Yes. In C++, yes. There will be some code, right, in the C++. In fact, there are a lot of different things that could be inside header. So header is no longer just the prototype. Okay, for C++, it has a full declaration and definition of function, structure, class, and template, implementation of inline, and the template in their code. It becomes more complicated because of C++, and in some case, impossible to keep it in one header. And you need to use the header to include another header or something. Okay, this means that in extreme cases, you could have a full declaration header, declaration definition header, and a implementation header. So even header has different function now. Okay, even header now have different function. It's for C++. So something like this one, you actually can put a template and then class object. And class object, this one actually is a prototype. This one is the prototype for it. So it's actually this one's my object forward.hpp. Forward.hpp. Okay, that's called forward. So actually people have this prototype for class way before it got defined. So forward declaration is a structure or a function I haven't implemented. So I put it into some HPP file or H file for people to see before he actually got the implementation. So usually a template like this will be put into the .h file or .h files. So that one, previous one, this one is forward.hpp will be included to my .h file, declaration.h file. So .h file itself can be included in the .h file again. So that one is forward. Then some people before my class already be able to use my object class already. Is that okay so far?
What?
Is that okay so far?
You can go back. I don't know what happened here.
You don't know about what is this? Okay. Number one, this file is called my object forward.hpp, and .hpp is the same as .h file. Okay. .hpp is the same as .h file, so there's no difference. But this one is called my object forward.hpp. So it just put a prototype for a object, but there is no definition. Okay, and this one got included by this one. Got included by another .h file. So basically, it's my object declaration h includes someone called my forward.h. Okay, this one's declaration.h. You know why? Why this? You know why is this? Because in front of here, actually in between here, you may have some other class use the my class, my object. I'm sorry. You can put something before that, and then actually my object already been defined in here. So you include this first, and then some of other class may be able to use my object. Is that okay? And later there is another implementation. There is another implementation.h includes my declaration.h again. Especially when you do template, because template cannot be put into the .cpp file. So this one actually again, this one you must notice this is not .cpp file. This one is .h file. You know why? Because your template cannot be put into .cpp file. So you have my implementation.h file include my declaration.h file include forward.h file. And this one is a .h file. This one is a .h file, right? This guy is a .h file, right? So you may be included by my main function, my source. So there will be another function file. There's another file to call my object source.cpp. Actually, that is the .cpp file. So this one, you have a real class definition, say my object, whatever. That actually define a real object, okay? And not my object because it's a template type. So you can have the my object of integer or something, okay? And that one actually include my object declaration.h, my object declaration.h, I'm sorry, my object implementation.h, and my object implementation.h include my object declaration.h, and my object declaration.h include my object forward.h. So actually, one module now can at most have 4 files, not just only one or two. In the past, it's only 1 or 2, just the .cpp and .h file. Is that okay? It gets more complicated now for CW+ structure. Yeah. Okay, but usually I don't go into that complicated thing. I would rather put all of .h file in one file and one .hpp file, because that really is actually too much. Okay, so .h file you can also put the define constant. Then actually you can actually use the inline function instead of the define macro in CW+. And now you don't need to use the external variable. Type define less important, but you still can use it. Emulation, structure, and classes. Okay, these are some issue for the .h file. So you still can use the enumeration in .h file. You still can define your structure and class in there. You can put your type define there, and now you don't have much need to do this external variable. And then usually the macro you no longer write it. You actually change it to inline functions, and actually you have a define constant. Define macro now usually use a constant integer or something more for CW+. Okay. So here is the initialization and finalization of constructor and reference. What's that? Okay, we covered this already. Okay, we covered this initialization and finalization already. This one actually is this different constructor. Okay, we talked about this different constructor in previous talk. Okay, and that one actually we have different way of using the constructor and deconstructor. Return value, we talk about it, okay? Inter-class relationship, okay? We haven't started here. So now, inter-class relationship is more important. We have the structural programming versus object-oriented programming. We need to think about the inheritance to create CW+ class, okay? And then use the composite, okay? And then static dynamic function, virtual function. So these are the different intra-function relationship. So structural program, you don't have object. Now object-oriented, you have the object has the data and operation together. Okay, so there are 3 important feature for object-oriented programming. Number 1 is data encapsulation. So that's actually private data, public method, and this can also be called as data abstraction. Second is inheritance. It's called extension, something called extension. Number 3 is the binding of the dynamic binding of the operation to object. Okay, these are 3 main principles for the object-oriented programming. Okay, 3 main topics for object-oriented programming. So here we have different terms. The object, we call it class object or class instance. And then instance variable, we call it private data field. Method, we call it private member functions. So in CW+, we usually call it function, but in Java, we call it method. Message passing is function call, okay? That's the left-hand side is the old time OOP terminology. So what is an object? An object has an operation and data. Okay, your data usually you try to put it as private. Operation you put it as a public. So you actually only can use the function to access the data. So inheritance hierarchy, you can have a vehicle, and this vehicle can be boat and wheel vehicle. And wheel vehicle can be bicycle or car, and car can be two-door or four-door. So this is a so-called inheritance hierarchy. And this one is the is-A relationship. This one actually called is-A relationship. What is is-A relationship? A four-door car is a car. A car is a wheel vehicle. A wheel vehicle is a vehicle. So basically, form a so-called is-A relationship. That means a car actually inherit wheel vehicle, and wheel vehicle inherit vehicle. Okay, this is called is-A relationship. There is another one called has-A relationship. It's not inheritance structure, it's actually ownership. Okay, I own you. So it's called ownership. Such as car actually can use or have a wheel. So this actually car using that. So usually is that in the car class there is something called wheel. W equals new something. So that's actually called has-A relationship. A car has four wheels, but a car is a wheel vehicle. That's two different relationships. Okay, that's the hierarchy. Now we have a topic for inheritance, visibility, composite, binding different. So here we are going into the OOP. Okay, here we are going into OOP for inheritance. Now I'll jump from C++ to Java. Okay, because Java show the OOP much better. So actually, I will use Java as example to explain what is OOP right here. I'm going to use an example. Okay, this one. Can you see it, Eric? Can you see it, Eric?
Yeah.
So right here we have different class and interfaces, okay? And let me actually explain it. First, because the reason why I'm bringing up here is because last time in C++ I talked about in this C++ class, we actually cover this thing called rectangle 2, right? So this rectangle 2, we have used a different rectangle, and we have rectangle.h, this different function and its implementation file, right? And right here, it has a rectangle as well. So let's look at the rectangle. So rectangle is actually, let me actually make the font bigger for you. Okay, let me close and open it again. Is that okay for the font? So we have a rectangle, right? And we have two private data field, W and H, and have one default constructor, one constructor with parameter W and H. And you can get width, get height, set width, set height, get area to string equals, and there is a draw function, okay? So this draw function I will explain it later. But other than the draw function, everything is fine, right? Everything is fine, right? For an object, you are fine with everything else, right? Hello? Hello?
Yeah.
Oh, okay. So this one is called a geometrical object. No, I'm sorry, rectangle. So rectangle have the W and H, and you can get width, get height, and get area to convert it to string or compare to rectangle, whether it's the same or not. I will go to explain this draw later. But let's look at the circle class. So circle class also extend the geometrical object. But anyway, circle has pi, has number of circles, has the radius. So circle, actually the area is calculated by different things. For circle is calculate the area. It is a get R, get D, right? But there's a get area. So get area is using pi R square, and rectangle is using width times height. But there is also two string and equal. So two string and equal, they are inherited from object. Okay. So now we have two different class. One is circle, one is rectangle. Okay, and both of them actually also for circle there is also a draw function. But these two actually extend geometrical object. So what is geometrical object? Geometrical object actually is a abstract class. It only has two methods. One is called get area. The other one is called compare to. So basically, I have a geometrical class, and then my rectangle and my circle actually inherit this one, and this one has a method called get area. So because here I have a abstract method called get area, so my children need to implement it. Because it's not defined over here. Is that okay? Any geometrical object is abstract class. You actually will need to have the definition for get area, and this kind of the abstract function in this kind of in C double plus is called virtual function. Say get area. You need to write something like this, and then write equal 0. A function prototype equals 0. You will define something called implementation. Equal 0 means in my abstract class, this get area is undefined. It's undefined, but it's fine. It is undefined, but it's fine. Actually, I'll get my definition from my rectangle or from my circle. Is that okay? Hello? Is that okay, Eric?
Yeah.
So in C double plus, it's called get area. It's called virtual. Okay, it's called virtual function. So virtual get area equals 0. You'll get some sort of virtual function, and that virtual function is for dynamic linking. But if you set it to 0, actually it's abstract, so it's incomplete in this geometrical object. So I have a hierarchy, have a geometrical object, and there is a circle and there is a rectangle. Both of them inherited the geometry object, but because my get area is not implemented, so my concrete class, real class, circle and rectangle, both need to implement the get area. Is that okay? And then my square is a class extend rectangle. So right here, it doesn't need the get area. You know why? Right here, it doesn't need a get area because the get area defined in the rectangle. So I have a side, so I call super side. So I don't have data field in my my square. So when I star, actually I call the super class call this one called what? Called super constructor side. and you will call side. You actually call super, that is the rectangle side. Okay, and then something like that. Okay, and then actually I will have this get side function, and then toString. Now let's go back to our C++. Okay, so I have built a rectangle class. Now I would like to build this square class. Okay, so before I do that, what I will do is, I'm sorry. Before I do that, what I will do is actually, I will create a new project. Okay, and this one is a console, C++, and I don't want to put into rectangle 3. We have the rectangle and rectangle 2. Now I'm going to create something, actually something new. Let me, right here, let me put it as geometric object. Okay, this is a class module called geometric object. So right here, let me save this geo project over here. Okay, save it. So I have a geo main function over here, right? Now I want to actually copy whatever file I have from. Let me copy whatever file I have in my this one called rectangle 2. Okay, so I go into my rectangle 2. I don't like the main. I copy these two rectangle and rectangle.h, copy over to my geo object. Okay, these are the two files I'll use. Okay, and then go back to there. Anything else? The project I don't need. Main function I don't need. Main function maybe would be a good reference, but it's not something I want to include in my new project. So right here, let me include my rectangle. So I will add to file with the rectangle and rectangle.h, two of them over here. Okay, so basically my main program, I can have this rectangle. I have a rectangle implementation file, and I have the rectangle.h file. Okay, so far so good. Is that okay? So in my main function, what I'll do right now is actually I need to declare using namespace std. Okay, and then here I need to include rectangle.h. Okay, is that okay so far, Eric? Hello,
Yeah.
Eric. Are you okay? So now let me open this main file. Okay, I just save this to actually help me to do not this one. Let me close everything and reopen again. Because I don't want to get too confused. So what I'm doing is like I try to minimize the confusion. Okay, so each time I improve a little bit by a little bit. Okay, so here I include something I may use. Okay, this one bool function still be very powerful script, so I just put it here. Okay, and then my main function, I probably don't need that many things. So here probably I would just keep one rectangle, two rectangle. Okay, I'll just keep two rectangle over here. Just create two rectangle to make sure I have two rectangle over here. So I have two pointer for rectangle over here. Okay, and then go back to my here. I have an array, and then I have this thing to string stuff. Okay, so right here, let me try this. Let me actually call. Let me actually include vector. Okay, using include vector. Okay. So right here, let me do this. I will do vector. Okay, what type of vector I will put in? I'll put in rectangle pointer type. Okay, I put in rectangle pointer type. Let me try if this works. Okay, so here I'll say vlist. Okay, and then my vlist will have pushback R1 vlist that pushback R2, right? So here I'm trying to demo it's a vector of pointer for rectangle, right? So here, let me do this. I have a for loop. Instead of using I less than 5, let's do this. Here, let me say this is vlist.size, right? And each time I get a pointer body and convert it to string. Okay, so this one should work. And this one is called, that's called main. Okay, main is fine. Main function is fine. Okay, using namespace. Oh, I have a typo. And then rectangle release. Oh, I'm missing that. I delete the angle bracket. And this one, what's that? What is that? Oh, it's no longer an array. So let me see. It's changed name already. So here I should not use that. I should use call vlist. Okay, that's the previous using arrays type. Okay. What's that? Rectangle. So this one, oh, okay, this one need a C double plus 11. Okay, so every time when you have some update, you better check with your compile once. Okay, don't try to jump too far because you write a new thing, you may not be able to handle it. Okay, now that. Okay, it's done. So run. So I print two of these. Is that okay so far, Eric? Hello, Eric.
Yeah.
So actually, this one I demonstrate the use of a vector, and then actually I have this one called rectangle.h, and then now actually I have the vlist including pushing into a vector item for 2 pointers, right? Now what the next I'm going to demonstrate is like, I'm going to demonstrate what I have done in my Java course. I would actually first demonstrate using square to actually extend the rectangle. Okay, I'm going to do that. So now that's actually do a new file. So I should have something called this one first. Save as. This one should call square .h. Okay, so I should have a square.h, square header file. Okay, so right here I save a square.h file. So I should have this one include I'm sorry, if not defined, squareh, okay, define squareh, okay, and then end if, okay. In between, I will declare something called class square. Okay, this, and at the end I put my semicolon. So this is a class I would like to have. Okay, so that's the class I want to have. So it will be similar to this one called rectangle.h, but it actually will have to extend the rectangle. So what I'll do is like here, actually, I need to put rectangle. Okay, so here, let me see. If you want to extend a certain class, so C double class is inheritance. Okay, C double class inheritance. To create the inheritance for C double class. Okay, so you have an A class, right? There's a B class. So you actually say there's a B class. This one is actually a ownership. It's not for inheritance. For inheritance, you need to do public A, okay, that you inherit, you extend. The previous one, this one has a relationship. This one is a inheritance. So here I would like to extend it and also using public extend, okay? Public extend for that. So I actually get whatever feature I have mostly from here, right? After that, I will need to have two sections, put in my public section and my private section, okay? And private section actually is usually for data, okay? Private section usually for data. But what happened to my private section now? My square actually don't have private data. So my private section actually completely not needed. So I only have the public section. Okay. So now I have something called my constructor. So I have my square, okay, and then I have my what's the data type for rectangle? Rectangle is using double, okay. So here I have the double side, right? And I have the rectangle. I put side, side, side. That is. Okay. What this means actually, I want to create something the same as what I have done here for my square and put my double side and then I code super. So code super will be something like this. Here I miss a semicolon, column. Okay, miss a column. And this one actually is just like super, coding the super. And that actually will call this rectangle double constructor, and you will be running this constructor double over here. Okay, width and height will be setting. Okay, and then after that, my class, I will have to have get size, and I have to do this get size and my my get size and my set size. Okay, so for my get size, actually I just copy. Okay, over my get size from Java is actually also good. And I just put this over here. Okay, I'll try to have a implementation file. Okay, so that's good. Here the same thing for the get set size. I do the same thing. Okay. Okay, so this one I don't need the public because I already have the public in it's different way of writing. So here I have these two functions, right? I have these two functions, and then there's another one called toString. Okay, there is another one called toString. So toString, I have different format for my square compared to the one I have in my rectangle. So my rectangle has a toString function, and then there is a template toString. So let me copy this toString over to my square, okay, because I want to override the toString. So here I want to override. So this one actually, the reason why I have this is like to override the rectangle. Okay, right here. To override the rectangle. And rectangle, there's a equals. I still want to do equals. Okay. Get height, get width is fine. Perimeter area is fine. I don't need to change anything. These are also good for square. So now I need to implement 3 functions. These 3 functions I need to implement. So let me copy this guy over to my new file. So here I need to new a file. I'm sorry, I don't want to do it here. I do it here. My new file, right? And I just pass it first. Okay. And then I need to save as my square.cpp. So here I have a square.cpp. So here, the first thing I need to do is like I need to include my square.h. Okay. Here I need to include the square.h. Okay. That's the first thing I need to do. And then here I need to put my square and then double column to specify the domain. Are these okay so far? Are these okay so far? Okay. So to put it's a dummy right here, I just do return 0. Okay. And this one, because it's void, so I don't need to do anything. This one is a string, so here I just do return empty string. Okay. These are dummies. And that I include a square.h. So I'm sorry, I include my square.h. So before that, actually I do include IO string, right? That's it. I don't know what do I need, but let me see. In my .h file here, I should also do using namespace std. Okay. So that's that. And this one, okay, let me put this, include IO string. Let me put this here, okay. So then in my .h file, I don't need to do that. Okay. And my square.h, I believe I still need to do include the rectangle.h. Okay, I need to include the rectangle.h. And my main function, now I should also include my square. I actually put it in lowercase, but that's fine. Since I put it in lowercase, let me just put square.h, okay? So I have square.h, I have square.cpp, okay? And then my square.cpp, I haven't implemented. So I'll get side, okay? The first one, I'll get size. So what I'll do is because I inherit from public from my parent function. So here I should actually just get h. Okay, I'm sorry, because width and height are the same, so I just need to get one of them. So let me check which one I have in here. It's actually get width. So here, let me just implement get width. Okay, and then set size. I have a size. So what happened is that set size, I need to update both width and height. Okay, if I got a new site, I need to update my width and height. So here, I should have a set size. I have this one doesn't have the set size. Let me check the rectangle. You have the get width, get height, but now set width, set height. Okay, so now here, let me actually expand it. Okay, so here I should have a void and then set width. just put it here is enough, okay? So it's like double W, okay? And here I say the data field WIDTH with my W, okay? And then the same thing, I just copy over. So this tool, because it's quite simple, this tool is quite simple, so I don't want to put it into the implementation file. So it's actually quite simple, okay? So here I have a H, here I have the height. Okay, because last time I want to demonstrate the function in here, but this time I don't want to waste my time. And also it actually is more complicated. But in my square here, I now has this one called set width. So actually here I have the set side. So here I should do what? Here I should do set width with my side. I also need to set height with my side. That's the setting the side. Okay. And here I have this one, get size, set size. Okay, it's a special function for it. And last one is toString. toString I'll copy from my my toString function in my rectangle. Okay, I just copy this over. Okay, I just copy this over from here in C double plus format. Okay, and then I just made a minor adjustment would be enough. Okay, so let me just pass over here. Okay, and here I just push down. Okay, and here I don't put rectangle, I put SQ. Okay, so that's rectangle, and I don't need to have the height now. I just try to get my width and convert that to string, and then here I need to plus, and then here keeping that. Okay. Okay, now I finish my implementation for square and get size, set size, my rectangle.h file included over here by the square, and my main function I include my square.h. Okay, I don't want to add anything yet, so let me actually compile first. Make sure that I'm fine. This one is width. Okay, what's wrong with the width? Boy set width, constructed take member function set width. This one is can only take member initializer. Oh, I see. I see. Let me see. Member initializer. Constructor can take member initializer. Okay, so function doesn't allow this. So what I would do is that I just do this equal W. Okay. It doesn't allow the function initializer, so I will do this height equal h. Okay, that's not much. Okay, go. And this one get width. What's wrong with that? I have an extra parenthesis. This one double width. Oh, okay. Okay, so it actually is private data field. So this one won't have the width. So I need to use get width. Okay, because it's a private data field for the parent. The child field cannot access it. Is that okay, Eric? Hello, Eric. Hello.
Yes.
Why this is not okay to put a width here? Why this is not okay to put a width over here?
Because you're using the .h one.
Why? Are you really following? You have
Yeah.
to stay close, okay? Is it because it's a private data field in the parent?
Yeah, so you
So
can't
it's not, you cannot use it in the child, okay?
Yeah, so you gotta use get with.
Yeah. So there's no, so this one's okay, right? Now I finish the square case, square case, right? The next one right here, I have this, so right now I can do this. I can do rectangle, right? Star S1 equals new square, okay? And then I put 4 in there, okay? But this one actually compared with what? With a square pointer. Let me just don't do anything, see what will happen, okay? So here actually now I have the V list. Let me put my S square in my square in the middle. So push back, and then I have a S1 over here, right? Okay. So I have a rectangle list, but I this time I need a square 4 over there. See what happened? Run. Is that okay? Now I have a rectangle 4 over there, right? Okay, this one apparently is actually called the one actually what? It actually called the one defined in rectangle. It's not actually called the one defined in square. So this one doesn't call. It actually called rectangle here. So what should I do right now? What should I do right now to make sure that my two-string function, my two-string function in my square actually will be a call instead of using the one in this one in the rectangle. What should I do here, Eric? You know what I'm saying?
Putting the toString into the .h.
No. In here, okay, in Java actually, here I have a 1 to string, right? Here I have a 2 string, right? For rectangle. And here I have a square and it has a rectangle. It has a 2 string as well. But these 2 string are defined differently, but my square inherited my rectangle, right? But at the wrong time, if I have something like array list as well, the Java will check which one I will use. Okay, if I have a rectangle, I'll call it rectangle one. If I have a square, I'll use a square one. And this one, I have the definition over here. Okay, so now save. Oh, go back to my main. Compile. It passed, right? Oh, this one got SQ. You know what happened?
Hmm.
You know what happened?
What?
I have a dumb, stupid problem here. I put the two. I put this.
What?
I put this here. But it's actually quite simple to use, okay? It's not really that complicated. What happens is like you just need to declare in a base class with .h with the virtual, okay? Then your child, you put a function like this, just like normally you declare a function, it would be good enough, okay?
Uh-huh.
And here you need to put everything like pointer of the rectangles class scenes over here, okay? Otherwise it won't work. So this one actually I include this one called square over there, right? This one actually I demonstrate so-called polymorphism, dynamic linking. Last time you remember that if I delete the virtual, only delete this virtual. Right here, if I delete this virtual, right? Only just delete this virtual. What happened is like it will actually call which copy? You will call the copy. I'm sorry. Why it takes so much time to react? I deleted it already.
Wait, go back
Where?
to main CPP.
Where?
Shouldn't it be capitalized?
Which one capitalized?
toString.
Oh my God.
It's the new one.
Save all. and then compile again. It should be static linking, okay? Now this one's still not getting it. So this one is called reveal all, reveal all. You know, if you don't reveal all, it probably just BO the one had to change, right? This one I go back to, right? So remember that, okay, here, I mean, here if I put that virtual in, when I do virtual, put the virtual in, okay? If I don't hit the reveal, instead I just compile, it will just change this rectangle and rectangle.h. Rectangle.cpp and the rectangle.h. So this one you run, I change it, right? It actually only affects this one. It doesn't affect the other one for the square. So in order to make it square, because it's a virtual, you need to do reveal all. And now when you run, you will get it, okay? Be careful for the reveal part. Reveal part is like, I have now, actually, I have a few things. I have the rectangle edge, right? I have the square edge. I have a square and I have a main, right?
Mm-hmm.
So if I make modification only here, I change assumption, right? You touch this one, compile, it just change this one. That old file got changed. The other doesn't change. The other doesn't change. So I do virtual, right? When I write virtual, that means like my rectangle would be virtual, right? And it automatically will update this one as virtual, but actually it is not recompiled. So what you need is like, what you actually is like, you need to actually recompile that again. So you need to pick this one for recompilation.
Mm-hmm.
You need to pick this one for recompilation. You need to actually pick this one for recompilation as well. Then both of them will be compiled. The things like first thing is like, we need to know that, okay, we have these two class, okay? We have a rectangle class, we have a square class, right? So right here it has a function called toString. Here it has another one called toString, right? If I don't put the virtual in, actually whenever you run, it will go this way. It will never go that way. Okay. Even if I in main, actually, I declare it as in main, I declare it as a square into the rectangle pointer. Okay. Even that, it will still go this. This is called static linking. This is called static linking. Okay. And then right here, if I want this one to be whatever square I want to run this one, I need to put virtual. I need to put virtual. So with that virtual, actually, when I go to the list, right, and every list one I go to string. When it is a rectangle, it will go this way. But when it is actually a square, it will go this way. That's called dynamic linking. Is that okay? So no virtual, it will be static linking. With virtual, it will be dynamic linking. Dynamic linking, we will look into its local copy. And because my square actually inherit a rectangle, so square will look, if there is no definition, you'll go to its parent. You'll go to its parent. If there is definition, then it's fine. So here, right here, if I say, I just take this one out. If I just take this one out, right? And in my .h file, I also take this one out. So there's totally no definition for toString, right? And now I save all, and then reveal. Must reveal, okay? Reveal will reveal the whole program. Okay, and I run. You actually all square, right? But now if I actually just put it back, because there is no definition in square for the toString. And now if I redo it, put it back, that means I define something to override my parent's definition, right? So that's fine. Actually I save all. But after that, don't do this compilation. You will just change the square part. You need to do reveal all. The whole program got reveal. And then you run. Okay, the square come up. Is that okay? Is that okay so far? This one is actually for inheritance.
Yeah.
So now let's close this project. Okay. Now let's copy the whole directory again. So now here I am going to do new project. This one console again. I will go to this one called geometric 2 obj 2. Okay. I'm sorry. Here I should create a new directory called geometric obj2. Okay, and go into this directory. And right here, I would say, I will actually put a geo2, okay, geo2 project. Okay, right here, what I will do is like the same thing. I'll copy those meaningful file over. Okay, the reason I do this is that I'm going to demonstrate some new feature called virtual class, virtual function. Okay, I'm going to demonstrate a so-called virtual function now. So let me actually go to my CPP. Okay, right here, let me go to my C double plus. Let me go to my this one, chapter 13. Okay, and from here, what is important is that the main is important. So let me actually no, main is not rectangle. Two rectangle files are important. So now let me copy over. Two rectangle, I keep the same version over here, okay? And then now I go back to my geometric. I copy two square file over. Okay. And again, in this project, let me add those files in. Add file in. I add this 4 file in. Okay. And then here, my main function is right here, right? So I, again, over here, I close everything. And then I open my geo objects main. I don't copy it over, but I will use most of them. So actually right here, let me copy the whole thing over. Okay, and then paste, right? So this one suppose in the same environment. So I right here, let me BO. Okay, and then actually I run. What's that? Oh, okay, I still forget the parameter. Okay, and then save this one. BO run. Okay, so I got this one, right? Now this is my main program and my rectangle. Now I'm going to create something called circle. Okay, so here I'm going to create one class called circle. One more class called circle. So let me actually new a file. Yeah. So here I save as circle dot h header file. Okay. Header file. Okay. So let me save here. Okay, this one is a circle file. Let me change the name. I use a lowercase, so let me don't try to create a uppercase. The file name I use a lowercase. So right here, I will do input So now we actually want to add a class called circle.h in here, okay? So I create these things over and then I create this one. Probably I will need I will need everything in a rectangle. Okay, I will need most of everything in rectangle. Let me clean this up. Starting from here to the end of the class. Okay, so I copy because square is not like a. I'm sorry, circle is not like square that actually derived from rectangle. So it's a new class. So here I need to change the name to circle, right? And then I need to have circle constructor, and circle constructor with a parameter, and I will actually create that circle with the radius. So here I put a radius r for it, an area I need it, parameter I need it, get width I don't need get width, I need get radius. All right, get height I don't need, get height I don't need, and then I don't need set width as well, I need set radius. Okay, and double I should have a R, and here my data field I should just write a radius. Okay, this one delete. Okay, so that one I'll say radius equals R. Okay, and then equals here I should put something in a circle format. Okay, toString is fine. This one is fine. Okay, so I have all of these, right? Then I need to create something called circle.cpp. So I need to actually copy this whole thing over, right? Because I need to implement all this. And then I new a file. So it is so far so good. Hello, Eric.
Yeah.
It's okay. Okay. Now I need a new source file. Yes, and I pass this over. Okay, and the first thing I need to do is that I need to include my circle h file. Okay, and then after that I need to set the circle domain. Okay, circle module specifier, and then I copy it to everyone. Okay, so V here, V here, Control V here, Control V here, Control V here, and here I have this one, Control V here. Okay, here I don't need to have this virtual because my circle is not a rectangle. I need to set this as virtual. So this one I did this virtual. Okay, and save, and then I go to my circle. This one I save as this one I call it circle.cpp. Okay, so this one's done. Now I just move everything to the starting point of that. Okay. So this one set radius, I already set it in .h file, so this one is not needed since it's easy. Take that out. Okay, so now I save all, go back my CPP. So I have a few functions I need to do. So here I also need to using namespace std, something like that. Okay, So first one I set with my double value r, so my radius equals r. Okay, that's the first one. Get area. I need to actually return pi times r radius times radius. Okay. Now I want to do this pi, so I need to find the pi from my library. So I need to do C double plus and the constant pi. Okay, it should be in how to use that. So mathematical value of pi. Let me try this one. Mathematical constants. It should be in mass, and then it's a mass m underline pi. Okay, so you need to include C mass, and it's m underline pi. So here I actually will include. So that's actually is C language is mass.h. Okay, so you need to do this C mass. Okay, so this one is what m underline pi. Okay, time radius time radius. So this one parameter should be written 2 times m underline pi times radius. Okay, get radius should be.
Wait, shouldn't that be between braces? Perimeter?
Yeah, this one actually is wrong. Okay. Actually, I put it in the wrong place. Okay. So this one should be returning radius. Okay. And the equals for this. So here should be a other. Right. And here I don't have a coordination, so this one pretty much is like return radius equals other that get radius. Okay. And the last one to string. To string one, actually we want to copy from square. So from squares.h file. Square.h file. This one's like this. Wait, what happened to this one? Oh, I need to have a square.cpp. Okay, so copy this one over. Copy to my circle. Okay, pretty much it. And here I just need to change SQ to circle. To string, I do get radius. That's it. Okay, that's all I need to know. So I need to do partial compilation on this file is fine. So Boolean equal, I need to return something on the Boolean equal. So go to my circle.cpp. It's a Boolean. What's wrong with that? It's a circle type. And here is circle other. Let me see, let me compile again, see what's the error message. So circle is not a type. Circle is not a type. Oh, I spelled it wrong, okay. I spelled the class name wrong. Okay, wrong. The next one is M underline PI is not declared in this scope. Okay, M underline PI is not in this scope. So in circle, that one, circle.cpp, this one is not that easy. Okay, let's look at what it should be. So here it actually should be CMass, mathematical expression, C double plus symbol. Wait, that should be fine, right? That should be fine. Let me copy again and see what it will be. Okay. M underline PI is CMAS, right? So actually I have this one, there's a PI, then there is a, there is, no, this one actually is master H. So that one is a, that one actually is fine, right? It actually is a macro. So if I include that, if I include a CMAS, should be fine. Let me see anything wrong with this. Was not declared in this, was not declared in this scope. The area is not declared in this scope. Okay, let me remove this STD. Okay. I have the two string. Here I actually need to include the string as well. Okay, let me compile one more time. So MI underline PI is not declared. This is actually weird. Let me try to see if there are something else I can find. It's quite tedious actually. So this one is M under something. It's under CMAS. I don't know why it actually doesn't work. M underline PI. Where that it's like this. So it actually defined in CMAS, right? So let me try this. Actually, this is stupid. I actually it should be something that I can include and then easily wrong. Okay, so let me see. CMAS and underline PI. So let me see. Here is undefined. Okay. Okay, so what it says like PI is non-standard. Oh my god. Oh my god. How can I know this? PI is non-standard. Oh my god. What's that? This is very stupid. It's a non-standard one. Okay. I don't know what's going on. But this is a simple constant. I don't know why it need to be so complicated. And it pass. My god. So this one, this one need to be a function. Okay, so that actually is stupid. Okay, I never expect that need to be have that to work. Okay, this circle class and circle.h work. Okay, but that's not the purpose for us to do this. Now I want to, because we are doing the abstract class, so I want to declare something called the one we have here. We have the geometrical object, right? So Eric, are you okay with this geometric object? We actually want to make this get area to be public. Okay, compare we don't implement right now, so we need to make a abstract class geometrical object. Okay, we want to have this class geometric object, and then has a method called get area. Okay, so here let's look at our circle. Circle, we have a circle, rectangle, everybody has an area function. So we actually want to make that area as abstract. So here actually I new a new file, and this one let me save as this one actually let me save as geometric object. Okay, and then it's H file, so I need to declare as H file and then save. Okay, inside here let me actually pass the thing I want to pass first. Okay, so that's the class I have, and here I have a public section, and there's only one function. I call it virtual area equals none. Okay, and not make it a abstract method. So right here say endif. Okay, in front of it I say if not defined, if undefined, and then here geometricobj underline h. Okay, then define geometricobj underline h. Okay, so this one is my .h file. And do I need to have my this one is the abstract class. Do I need to have my CPP? I don't think so. I don't think we need the CPP at all. So what I will do is like I have this geometric object. So inside my rectangle.h right here, let me actually include. Here I say geometric obj.h. Okay, and here actually I should extend public geometric obj. Okay, I need to actually extend that. And here I have an area, that's fine. Okay, and I have the area definition over here. I actually need to copy this guy over to my circle.h. Okay, and then my circle.h. Right here, I should add like public, and then I control V again. I delete the use the same, delete the include same. So I actually just declare it as this. So this one actually I formed a relationship. Originally I have the rectangle, right? I have a rectangle class. And then I have square class inherited, okay? And then I have circle class. Now I have a geometrical object class. Both of these actually implemented, and this one actually is a abstract class. Okay, that one is a abstract class. So what I'll do is actually now let me actually just clear this one. Okay, and I have that geometric object.h file. So my square, I don't need that. Okay, square because it's under something else. So I need to copy this guy back to my main function. And this one I need to be in front of my rectangle. And here I also need to include my circle. Okay, so I have my circle included here. And then here I have this geometric object. I have square. I have circle that actually rectangle.h. I include this and extend this. My circle, I have this and extend this. The link is hooked up. Okay, right here I have this. So this time, let's don't do this toString stuff. Okay, this time don't do this toString stuff. So this time let's do. No, this one actually let's do here. Let's call the for each of the virtual list. let me just calculate the area for it. Okay, just call a get area, and here I use the what? I use the double type. Okay, and here I say area like this. Okay, like this, and then right here, let me see, and then okay. And then here, actually, over here, I also want to do virtual and toString, toString. Okay, this one actually I have the implementation. So here I also make it a abstract class. Okay, and then this one I have this one as a abstract class, so I can share the same definition to everybody else. So my circle had the definition, my rectangle has the definition. Okay, my square has its own toString definition, so that's fine. But my main function, actually right here, I should have this one. Let's call this one as area, AX, okay? And then the previous one, I still need to keep that. So I need to have here called string, still A equals this scene I copy over. Past, okay, and this one I call toString. Okay, and instead of printing this guy, I should have copy and copy done. Okay, the first one I just print out I still printing now that string for the list. Okay, the second one I calculate the area. So second one I just calculate the area and then say AX. So area equals. Okay, so I print out the point and then that's something like that. So right here, instead of having that as the so-called rectangle, here I use a geometric object. Okay, instead of having that, I put this to here. Okay, so under that, everybody has the toString and everybody has the area. So I can actually use this for everybody. So this one actually I copy this, pass here, pass here. Okay, and here I just pass again, and here star R1 equals new circle 10. Okay, so here actually I made this guy as geometrical object, and at the end my relist that push back as R. I'm sorry, this one should be R1. Let me try O. Okay, because they're circles, so I mean try olives. Okay, so then my O1 got added in as well. So I change everything to geometric object. A geometric object actually is a abstract class. So we form something like this. We actually form a geometric object. Okay, whatever shape it is. Rectangle, inherit this one for circle. Here have two method, area method is abstract. We also have this one toString method, which is abstract, and they have the definition down below. And then here, actually right here, we have this guy called rectangle, right? So it has new definition of area and toString, and then we have a square over here, okay? So that's that. Now that's actually, so when we actually traverse through all of the object under geometric object. The pointer actually will access each individual cell, and then each individual cell will be able to convert to string and area. Okay, so now let's actually reveal. Reveal here, I typed it wrong, so here I have this include. That's reveal. So here, oh, I have the same error. So like I probably have the typo many times. Yeah, I had a typo many times. So what's that? String is not a type. So here I need to include. So sometimes don't feel frustrated when you have the error, because you really don't. Sometimes it's easy, you forget something. Okay. So right here, string is not a type. Oh, then it's using namespace std. So set all and run. Expecting semicolon. Okay. You know, because C++ has so many grammatical rules, we just try to clean one by the detector. So double area. So this one, let me see, concrete virtual return type, double type. And then the geometric object. Oh, here it doesn't have the data type. So let me put it in. Okay, you know, there are several bugs we found already, but that's something we usually will have. So that is once pass. Okay, then that's wrong. Okay, rectangle area 12, circle square area 16, rectangle 27 area 14, circle 10 area 314 and 159. Is that okay so far?
Yeah.
What do you learn over here?
To make the geometric object.
Yeah, and then what's that for? And what's the purpose for this? If I don't, what will happen? And if I have at least geometry, what's the good about it? That's about the definition of why we need to have the object class or interface. Why we need to have object class. You can call it an object class, but it actually is also an interface, because it actually don't have data field. It actually the same as an interface. It's just like in Java, you have this one geometric object. This one is a object class, but actually you have a concrete method for Java that's allowed. But here, this one actually it doesn't have the concrete method. It's somewhat like more like this interface draw, only have a object method. So here you have two object methods. So what's these two different object methods for? Basically, what's the interface for? When you have an object class and interface, what's that for? Why you need this? And in C++, you don't have that. So we just make sure if you have two methods to be virtual and also it to be object equals 0, it means object, no implementation.
It means it finds its own.
Everybody under it finds its own, right?
Yeah.
And why we need to have them to find its own? What's the purpose of having the interface or object class? If you know, you say you know. If you don't, you say I don't know.
I'm not sure.
Okay. So here actually we have the main class, right? All of these four are considered geometric object. So what's the purpose for this geometric object class, object class for? It's kind of grouping everybody together, right?
So it's like the vehicle in your diagram before?
Yeah. We actually group everybody together, and then we can do a collective measure on everybody else, right?
Mm-hmm.
So it's like a student, right? Student, and student you have high school student, right? You have college student, right? You have actually have the graduate school student. And the high school student, you have boy and girl. Something like that, right? But if you do everything like calculate GPA, all of them should apply, right? But if you say calculate AP course GPA, maybe only high school can apply. You know what I'm saying? So what kind of the abstract level you need to have or inheritance level you need to have? It depends on how you group the data. So right here, apparently, I group my square with my rectangle. And then I group my square, rectangle, and also circle together under something called geometric object. And with that, my vector can group everybody together. That's why the compound database is useful. Some of these compound database like vector or array is quite useful. So there's a new array class that do the same thing. New array class, you can call geometric object and then 5 of them or something. You can create something like that, right? This type of data type is we using the template, and you can put everything into there. So template is useful for this purpose. And then we can calculate everybody's area and also print out the circle object type, right? So each time we access one element from the virtual list, actually it's called vector list, okay? And then take that one out, print out is to string and calculate the area, do it. So other than that, every class over here, they pretty much have most of the things have their own definition, right? So every time you develop one module by one module, right? You know, I started from rectangle, okay, I denied it, finish it, I check it, compile, see whether there's some error. Okay, now the next one I divide square, that's under my rectangle, okay, check it, fine, pass. Next one I check my circle, okay, circle pass. Now I add something called geometrical object on top of them. So this one actually is called bottom-up design. I design from my rectangle, circle, and then I put my geometric object on top of it. You can also do top-down. I design a geometric object first and then put something under it. But my implementation, I do bottom-up implementation. Top-down design, bottom-up implementation. That's usually that's the best way to do it. Okay. So now let's go back to our chapter 13. Okay, so we actually had this one, finished this one called virtual function. So let's go through our slices. Okay, let's go through our slices. So I pretty much finished the the last week we built a class, rectangle class. This week we actually create a square class and then add the inheritance feature into there, right? Within the extension, and then now we add a virtual function with implementation. So rectangle has an implementation, square has an implementation. And the end, we add one more circle class in, and then we put something in the geometric class that actually, that class actually is like an interface. There's no data, okay? And there's no concrete method, so it's actually an interface. But an interface is fine. It just group everybody together. But it's still a class. In C++, there's nothing like called interface. In Java, you have something called interface. And interface only has the method just like the one we have. And in this one, actually, it is similar to public abstract. Just like this, okay? If you don't write anything, something like this. But you can just put this, that is fine, okay? That is actually a interface. And under that, we have something called geometric object. And this one actually is an abstract class, but it has a concrete method. With concrete method, you can no longer be an interface. So we can only use that as a abstract class. But in C++, there's no abstract class, there's no interface. So if you want to have an interface, you just do a normal class, but put only the abstract method over there. That's something you still need to implement there. Put it as equal 0. And then if you want to design something called abstract class, you need to at least have one abstract method in there, abstract function over there, as a minimum requirement. So after that, actually, we try to have our main program. We test through a vector that actually group everybody together and print out and calculate area. Okay, so let's go through our slices. So two parts. The first part we build a class, and now we actually do this one called inheritance and polymorphism. So inheritance is actually like extension. So we have a base class like rectangle. We have derived class like square. Okay, that's inheritance. So you just add the new function that you actually want to modify it, or no definition from your parent. You only add those data in there. So actually you, when you do if this EST time is inheriting time, you just need to include both of them into your CPP file. Okay, you need to input both time and extend time over there. So that's fine. And now that's actually time. That's class. So it actually extend public time. Okay. So say time is a public base class of the derived class this. Okay. So it's a base class, and the one inherited is called derived class. So as a result, all public member of the time is also public member of EST time. Okay. So that actually is called accessibility. Inheritance does not imply accessibility. The derived class inherits all the members of its base class, but both public and private. Okay, and the derived class cannot access the private data member. Okay, you get the data field, but you cannot actually access it. So constructor rule for derived class. A runtime base class is implicitly called first. So you actually, if you want to call the non-default constructor, you actually need to do your derived class, derived constructor. You need to put your base with parameter here. Okay, if you don't do that, actually you actually will just call the base without parameter. Okay, so that's something, if you extend it, you need to be careful whether you want to do it or not. That's called super. Okay, super. Yeah. And here this is execution sequence of the constructors. So class 2 is actually extend public one. That means this one actually is a chart. So my class 2 extend my class 1. So my class 1 is the base constructor run first and then second. Okay, and then class 3 actually has multiple inheritance. It extend 1 and 2. So you run one constructor first, and then 2, and then 3. Okay, and C double plus allow multiple inheritance. So that's the order you will run the constructor. And third one, you have public 1, virtual 2. Okay, so that what happens is like virtual class constructor will run first, and then you will go public 1 and 3. So actually virtual will run first and then public, and then do 3. And 3 actually extend 2. Okay, but 2 actually extend 1. So you go 1 and then 2 and then 3. Okay, this one is under the assumption that 1 inherited by 2, then inherited by 3. So you will run 1 versus 2 and then 3. Okay, so that this one tell you the sequence of which constructor will be run first. Is that okay? So that's that. This one we just save for you to read. Okay, responsibility are operation implemented as a C double plus function. So action responsibility are operation that perform action. Knowledge responsibility are operation that return the state of private data available. So responsibility is something you need to implement. So if you have the abstract method, you need to do that. What responsibility are missing? time class, you need to have this one. So if you have some abstract method being defined, some class you need to actually implement that. Okay. So this one I will just pass it. Visibility you have public, private, and also have protected. Okay. So two reasons to put things in the declaration, so programmer can get them, so a compiler can understand it. So that's why we need to put something in the .h file. At the very least, the compiler need to know the size of the object. So basically, each of the function you at least need to put the integer there. You don't need to put x there, no, but you actually at least need to put the integer in the parameter list so that the compiler will know the size of the function. So that's why private data field have to be in declaration as well. C++ distinguish among public class member can be accessed by everybody, protected only the derived class, and then private only accessed by the same class. Okay, C++ structure is simply a class whose members are public by default. Remember this statement.
Mm-hmm.
So structure is something you can always put .x.y, right? So it actually is public by default. So there is no public section, private section. That's the only difference you have on structure and the class. Other than that, they are two same thing. Okay, they are two same thing. And C++ base class can be public, private, and protected. Okay. C++ inheritance and readability. This one you circle, extend shape, circle, extend shape, protected shape, circle, extend private shape. And what's the purpose? We actually just look at the table we have here, right? So public inheritance means you don't drop down the public accessibility or protected accessibility. Only the private you cannot extend, okay? Cannot access. And then if you declare as protected, everything will drop to protected or below, okay? And private extension, you will drop to private, okay? And let's go back to the previous pages. See there any story you need to read. So this one, visibility, that's okay. So let's go. Has a relationship. Has a relationship, we have has a, and you can explain it as made of, library is made of books, and library need a book, or library is a fixed account is a bank account. This is called inheritance. When you find out, you read it, is a relationship, it actually is inheritance. Okay. Other than that, it's all like has a relationship. So composition or containment is actually I have something. Okay. String has a character array. That's composition. Okay. So that part actually is fine. We just pass it. Time card is okay because we actually finish those different things. They are something. They are sample code you can download to run. Okay. So here we just focus on our sample class. So order in which constructor are executed, given the class X. If X is a derived class, its base class constructor is executed first. Then the constructor for member objects are executed. Okay. Finally, the bodies of the X is executed. Okay. First from the base class, and then the constructor of member objects. Member object means your what? Member object means not yourself. So basically, if you have class X, right? Class S actually inherit class Y, right? But this class S has a string class V, use a string class V and use a matrix M, right? So with this, actually, you will run. With this, you will actually run Y's constructor first, and then V and M, and then at the end run this S. Okay. The initialize is data field first. So that's the way it is. Even though the the string and the metric is not in the inheritance structure for the class. Okay. When the type of the formal parameter is a parent class, the argument used can be the same type or a distant class type. Formal parameter is a parent class. The argument used can be a same type of formal or a distant class type. You know what this is saying? So say, for example, you actually have a rectangle, right? And then there's a measure called compare to, right? And this compare to actually has a geometrical object here. So actually rectangle can always be compared to geometric object, right? So this is called the type of the parameter is a parent class. Okay, so the argument can be same type, so it can be a geometrical type and it's distant. So your rectangle compared to here, you can put rectangle, you can put circle, you can do square over there. Is that okay?
Yeah.
So that you can actually do comparison to them. And maybe you write an area or something. Static binding is that if you don't put any virtual, it will be static binding, and it will be determined the compile time. Okay, and compile time will depends on if you declare as a rectangle pointer, even though you put a square object over there, you will still be using the rectangle definition for it. Okay, dynamic binding is that you must put a virtual in the root class that you want to have the dynamic binding. You want to check its subclass to if there is a implementation that rectangle. If you want to put that, you put it over there. If you want to share by all of the geometry object, you put the area and also the toString as the object class, object method. Okay, so that's the virtual member method. So basically, you can put virtual, and then that method can be shared by. So all of its subclasses, okay, will have the different definition. It allows you to have different definition for that virtual function. Static, you don't allow it. So this is called polymorphic operation. Okay, whatever polymorphic operation is like a function actually like this one compared to, and then you use a geo. This one is called polymorphic method because you can operate on object of different type, right? And a polymorphic class is like a container. Say I have a vector, right? And then I put something in here. This is called polymorphic container. Sometimes the container can only put something like only geometrical object. Okay, so here you have a polymorphic method and polymorphic container. Okay, actually for polymorphic there are three types: polymorphic method, polymorphic container, and so on. Polymorphic iterator, but iterator we have not touched yet. So there are three types of polymorphism: polymorphic method, all function, polymorphic container, like vector type of thing. Third one, polymorphic iterator, that actually for you to do for each loop or something. These three are the polymorphism. And the polymorphic method mentioned here is about polymorphic method that actually can work on something of different data type. Okay. And the vector we have is actually a polymorphic container. It contains rectangle, circle, and also the square. Okay. So dynamic binding require pass by reference when passing the class object to a function. So it's something that we can, you need to have a polymorphic method. In the declaration of virtual function, the word virtual only need to put at the base class, and anything under it will have that feature. Okay. If a base class declares virtual function, it must implement that function. Okay. You have a base class, you must at least implement that function at the base class, unless you set it to be 0. Otherwise, you yourself need to define that. and the children may or may not define it. You can actually determine that, okay, I will use my father's, or I will use a new one. So derived class is not required to re-implement. You can have that, or you don't need to have that. But if you set to 0, if you set to 0 as an abstract method, then the derived class should always has that. Slicing is actually get the argument by by part of the parameter. So this one actually is like having the default value for it. Okay. So copy of argument is sent to the parameter. Only common data field are copied, and the object of the child class is passed through a object of the parent class. So that's that. Okay, that's a slicing problem. Passed by reference is okay, we know. Conclusion and object and class. So object-oriented design, identify the object and operation. That's in the building a class. The previous lecture we covered that. And then determine the relationship among the object, inheritance, polymorphism, and also has a relationship. 3 different types of relationship. Polymorphism, you need to determine whether I should have an object class or not. I should have an interface or not. I should have my certain function implemented at a certain level or not. And then at the end, design the driver. The driver is a main.cpp. Someone do testing. Is that okay?
Yeah.
That's the procedure you need to do. Think about what kind of object I have. Okay, I need to have rectangle, square, and circle. Okay, and then do those set method, get method, and then to string and compare. Okay, finish that. Then I have 3 classes. Now let me analyze who actually will have what definition, and should I re-implement it in square or not. Okay, so you build a class by class, and when you add a new class in, you need to think about, okay, my square just need to inherit my rectangle. Then I don't need anything else. Something I don't need to re-implement. Okay, at the end, you finish the whole different classes. Now let me do testing. Then I design and testing the driver. Is that okay?
Mm-hmm.
This is a procedure for object-oriented design.
Okay.
Okay, so object-oriented design, application domain, the aspect of the world that we are modeling. So there's an application domain. There's a solution domain, the program that solves the real-life problem. So you have some problem like a bank account, then you need to have a bank account class to handle that. Okay, check account, bank teller, and these. Okay, so you need to know about.
I feel like using objects and classes is better than using structures.
Not really. Structure is actually just a class without.
But you can adjust, or you can use like public and private and other stuff. I don't know.
It is more detail. It's in more detail. So some simple class, I would rather use structure. Some very simple, like just like a point, getting x and y, those kind of thing, right? But if something like this rectangle and circle, you need to share some area function, and you would need to be grouped with the circle. Then structure cannot do it, right? Then the structure cannot do it. Is that okay?
Yeah.
Okay. So identify the object and operation. You need to find out what kind of object and operation. So just think about, I would say, if you want to build a simple class, single structure, if that can do or not. And actually, tomorrow or some other day, I may teach you to do linked list for C++. And the linked list still need to, you would still rather use structure instead of class. That would be simpler because you don't need to care about the public privacy. Okay. And then you need to determine the relationship among class, saving class, and then different saving class, saving account for it. Saving account or the different saving account. Build the inheritance level. So first, think about what kind of object we need, and then think about the relationship among the different objects. Okay. So implementation for this design, we will actually go into, say, stack, queue, linked list, those kind of things. We will start to use this OOP knowledge to deal with that. Okay, so we need to do that now, later, okay, in later classes. So choose a suitable data representation. Is that I want to use a structure, or I want to use a linked list, or I want to create a new ADT like queue or tree or something. And then after that, determine the operations, okay? And then determine what kind of operation I need to have and do top-down design, bottom-up implementation, okay? And then at the end, you need to design the driver the program. So the program, main program is the glue that put the object together. And in C++, the driver become the main function. The driver have little to do with the design process. Okay, those are commands or something. And it just need to take care of how to coordinate the different objects and putting them to work together. Okay, so at the end, we had a case study for the appointment or calendar program. But because we actually do that, this whole geometrical object one, so we kind of just save it. Okay, thank you for today. Bye now. Bye now.